I'm Wild Bill, and this is Wild Bill's take on crop circles here on the 14th of January 2026. Elephants spend 10 to 18 hours of each day eating to stay alive. Elephants aren't ruminants, so they don't ruminate or chew cud. It's even tougher for them, as they only absorb about 50% of the nutrition from each bite. That is why elephants migrate. If they stay in the same place a few days, they'll consume all the forage and tons of water and begin to starve. 10 to 18 hours of pulling, biting, and chewing and drinking. Lucky they've got trunks to help gather and pull, and some marvelous molars for mashing all that plant fiber into digestible pulp. Imagine having to sit in front of the TV 10 to 18 hours a day, eating potato chips at, oh, we already do. Never mind. Now let's look at a sauropod. You know, a long-necked dinosaur. It's a whole hell of a lot bigger than that elephant. It has no trunk or heavy munching molars. All it's got is a tiny mouth compared to its size. Current thinking entertains the notion that these blasphemously big beasts might have maintained an elevated body temperature, been warm-blooded in other words. That means they'd need more food per unit of mass than any lizard, snake, or crocodilian. So how long must this behemoth of the plains spend eating every day in order to survive? More than 10 to 18 hours? If it did, it would have to migrate, just like modern elephants. But how far can you migrate in a couple of hours? And don't you have to spend some of the time in sleep? What's my point? We've left a monstrous hole in our understanding by not considering the amount of suitable plant food there was in the Mesozoic ecology. If sauropods traveled in herds, which seems likely given the evidence, and each sauropod had to eat a ton of food per day with those tiny mouths and insignificant teeth, a traveling herd would act like a prodigal lawnmower, stripping all vegetation bare in its path, crushing the rest flat under titanic feet. And during its yearly migration, the traumatized plant material would have to recover sufficiently so the herd could do it again next year. And you can't do that in the ecologies depicted in textbooks and in popular illustrations. A sauropod herd could not feed itself on the plains, nor along flat riverbeds exposed by the summer drought. My premise, we've got sauropods all wrong, or we've got the plant life of the Mesozoic all wrong. It's not just that animals don't get as big anymore. We have more energy-dense plants today, too. Grasses are new, remember, as are flowering plants, angiosperms. So, where could a Jurassic or Cretaceous sauropod get enough food to grow to adulthood and maintain a healthy herd life? I don't know. And frankly, I don't think paleontology does either. But, and it's a big but, it suggests that the Cretaceous ground clutter was too dense, so dense that other animals would have to follow the sauropod herds just to have room and space to move. A stupendous amount of plant life, so much that all animal life would have to live in the wake of the sauropod herds. Now that would make it a lot easier for big predators like Allosaurus, Gorgosaurus, or my old crush, T-Rex, to find suitable prey. And it would be blooming difficult for that prey to escape, too. So imagine the dinosaurian world as a tangle of vines, creepers, tall conifers jutting out from that morass in an effort to maintain enough sunlight to keep growing. The only breaks in that coverage would be the various sauropod game trails. In reality, the course of the big animal's desperate search for food. As an alternative, imagine if each sauropod picked a spot and slowly turned in a circle, creating a huge clearing as it mowed all the vegetation down for food. A herd would pause to strip bare 100 crop circles, then move on for an hour, then create another nest of crop circles. On and on, forever. Either way, as the sauropods vacated, the other life would crash into those openings, forage, mate, and die under the sharp banana-shaped teeth of T-Rex or its fast-feathered friends and cognates, among the smaller types. From a drone, the environments would appear a Celtic quilt of parallel patterns, the tracks of the sauropod herds on migration through a land of plants so dense and thick, no animal bigger than a mouse could move through them at speed, or at all. Wild Bill Cox, 14th January 2026. Now for the fun. I'd like to take the time to spin you a Wild Bill narrative. Wild Bill on, did sauropod dinosaurs have a crick in their neck? If sauropods needed that much food, or a calorically equivalent amount of easy-to-digest alternatives to nuts and berries, yuck, Yogi Bear, where are you now? What about frogs and salamanders? Sauropod teeth were tiny, peg-like, and weak, leaving them useless for eating, tearing, or chewing through plant material. Sauropod teeth were more placed and shaped for straining or filtering. Today's largest animals are the great whales, and these are suction filter feeders. What if sauropods sucked up necks full of pond, river, or seawater and sluiced it back out again, retaining all the small fish, tiny crustaceans, amphibians, and most importantly, the zillions, yes, that's a number, it's a one followed by as many zeros as you want, of tadpoles and mosquito larvae in that water? That moves the sauropod way up the food chain to a place where every mouthful becomes a gold mine of nutrition. Oceans feed large animals all the time, always have. Hopefully, they always will. Why not sauropods? The idea of a brachiosaurus spending 22 hours each day trying to speed strip enough pine needles from giant fir trees before it can starve to death seems specious at best. Wild Bill, 14th of January 2026. And I will separate the sauropods into two types. The current thinking is some sauropods were browsers, stripping trees of their branches and leaves, and others were grazers, eating everything near the ground. So not only do you have the problem of feeding such a large animal, you have the problem of specialist feeding such a large animal. Wild Bill.